Hi, this video is explaining question number 18 on the 3-3 assignment. And this question, you're going to be using your sum and difference identities to try and find the exact value of tangent of 19 pi over 12. So this question is a little bit different from the ones that we did in the examples today in the notes, because this angle 19 pi over 12, if you just add any of these values that we found in the first quadrant, they're not going to add up to 19 pi over 12. Because if you think about 19 pi over 12, that's equivalent to 1 and 7 pi over 12. And so it's going to be actually end up being in the third quadrant, and you're going to need to add some larger values here rather than the ones that we just did in the first quadrant. So sometimes you're going to need to step out of your first quadrant and into the second or possibly the third or maybe even the fourth. So one of the ways that can help you, instead of trying to list out all of them, is you can look at 19 pi over 12 and think of one of these ones that are in the first quadrant and subtract from there. So if you subtracted, let's say 2 pi over 12, that would give you 17 pi over 12. That would not be able to be reduced. If you do 19 pi over 12 minus 3 pi over 12, that's going to give you 16 pi over 12. So 16 pi over 12 could be simplified. You could divide the top and the bottom by 4, and that would give you 4 pi over 3. That's something on the unit circle, so that's possible. You could also do 19 pi over 12 minus 4 pi over 12, and that's going to give you 15 pi over 12. You could divide the top and the bottom by 3, and that's going to give you 5 pi over 4. So that one's going to work. So you could do a combination of either you could do 16 pi over 12 plus 3 pi over 12, or you could do 15 pi over 12 plus 4 pi over 12. There's more than one way that you can do these. So I'm going to choose to use 15 pi over 12 and 4 pi over 12. Again, you could have picked the other two as well. Both of them would work. You just need to find two things that are going to add together to give you 19 pi over 12. So I could write this, instead of saying 19 pi over 12, I could write it as 15 pi over 12 plus 4 pi over 12. And then I'm going to simplify that. 15 pi over 12 is equivalent to 5 pi over 4. And 4 pi over 12 is equivalent to pi over 3. And so once I've done that, now I can use my trig identities. I'm going to use the one with the tangent where I'm adding. And so I'm going to get tangent of my first angle plus tangent of my second divided by 1 minus tangent of the first times tangent of the second. So I'm just rewriting that formula, and now I'm going to try and use the formula. So as I'm using the formula, I want to evaluate. Here I have tangent of 5 pi over 4. Let's think about what that looks like. 5 pi over 4 in our unit circle is going to end up being right here. And since my reference angle is pi over 4, I know my x coordinate is negative root 2 over 2. My y coordinate is negative root 2 over 2. If I divide, tangent is y over x. If I divide y over x, they're exactly the same thing, and I'm going to end up being, that's going to end up being equal to 1. And so tangent of 5 pi over 4 is 1. I'm going to replace that everywhere where I have a tangent of 5 pi over 4 in both of those two spaces. I'm going to make that equal to 1. And then I want to evaluate what's happening when I have tangent of pi over 3. Pi over 3 is right here. That's going to be 1/2 and root 3 over 2. If I do tangent of that, I'm going to have my y coordinate divided by my x, which is my y times the reciprocal of x. The 2's can cancel. It's going to end up giving me root 3. So this is root 3, and whoops, that is root 3. I'm just replacing the tangents of pi over 3 with root 3. And so I can simplify this to be 1 plus root 3, and my denominator here, I'm going to have 1 minus root 3. At this point, I need to try and rationalize this. And again, I'm going to use that little trick of the conjugate. I'm going to multiply here by 1 plus root 3. I'm going to do the same thing in the numerator. I can do that since I'm multiplying by 1. This again is called the conjugate. And it's a little trick that we can use to try and help us to rationalize when we have a rational number in the denominator that's being added to something else. So if we go ahead and simplify that, I'm going to distribute the numerator. 1 times 1 is 1. 1 times root 3 is root 3. Root 3 times 1 is root 3. Root 3 times root 3 is just 3. And then in my denominator, I'm going to have 1 times 1 is 1. 1 times root 3 is root 3. Negative root 3 times 1 is negative root 3. Negative root 3 times negative root 3 is negative 3. These two rationals are going to cancel out. And so I'm going to end up with my numerator here is going to be 4 plus, I have a root 3 plus root 3 is going to be 2 root 3. And then in my denominator, I have 1 divided by negative 2. I need to simplify this a little bit further, so I'm going to take my numerator and I'm going to divide by my denominator, and I'm going to do it again. Essentially just taking each of these terms in my numerator and dividing by negative 2. And so 4 divided by negative 2 is negative 2. I have a positive divided by negative, so that's going to end up being negative, and those two 2's would cancel. So I'm going to get negative root 3. So my exact answer, again, without using a calculator anywhere here, is negative 2 minus root 3.